up next, we got Jay Beale. Now, Jay is a longtime friend of Sans, and he's been in information security for a long time. If any of you remember Bastille Linux from way back in the day, Jay is one that is responsible for that. He also led the CIS Linux standard, Center for Internet Security's Linux standard. So if you have any questions about, hey, why, when you turn on everything that the CIS standards recommend, why does your system not work anymore, right? Hey, you can add those to the Slack channel. Now, Jay, in addition to his work at InGuardians, has been busy over the years. He's contributed to 9 different security books. And currently, last couple years or so, Jay has really been focusing on Kubernetes and Kubernetes security, which is what he's going to be talking with us about today. So Jay, I just want to double check, do a quick sound check and a video check here. Make sure you are there and you can share your screen. And I'm going to hand it over to you.
Thanks a lot. I appreciate it, Frank. And those were really kind words. Thank you. Cool. Yeah, let's see if I can just click go on that. Awesome. Cool. And I'm just going to shrink, just do the Zoom window, play around, and here we go. Hey everybody, it's good to be here. I can't wait to talk to you in Slack afterwards, and I'm really it's really exciting to me that there are quite a few talks on Kubernetes and container security at the summit this year. This is definitely becoming a bigger part of all of our work lives, and it's something I'm really passionate about. So hopefully you'll have a lot of fun today. Frank was really kind and kind of talked about stuff I've done. I replaced the textual bio now that nobody reads because it's a sea of text with a graphical bio. So hopefully that's at least a little bit more comprehensible or fun. Yeah. So let's see. What are we going to do today? I'm going to talk about I'm going to take you through an attack. We're going to spend almost our entire time here in demo. And that attack's going to be a multi-cluster attack scenario. We're gonna go through and hit 3 clusters and go through and abuse a few technologies, and you're going to see that happen and right up. And after we're done with that, I'm going to talk a little bit as time allows here, and then more in Slack, about defenses that can break the attack path that you're going to see today, and break, honestly, lots of other attack paths. I do trainings at a number of conferences, and then also privately, and my whole way of looking at it is very much I'd like to do defense by way of attack, by way of looking at like what can I do? And then I can look at the defenses, and instead of defenses just feeling like a bunch of, kind of boring check boxes, that I have to go through. I know what the defenses do. I can prioritize. I can prioritize my effort on them, and just and do it from a place of knowing how they actually broke real attacks that have done or that we've done. So cool. I'm just going to give you a really quick review, given the nature of this conference. I think we generally know what Kubernetes does, but I'm going to give you just like a 3-slide quick review. The short version is it's basically you can think of it as a software-defined data center that happens via container orchestration. If you read one of the creators of Kubernetes paper on how Google runs its data centers, that really teaches you a whole lot about what Kubernetes does and why. It's really, really neat. And the biggest thing, I think the biggest thing to know about it is 2 things. The first is the operators of the cluster, the users of the cluster, are basically supposed to define how they want things to work, and Kubernetes will eventually get them there, but then we'll keep them there even as things change, even as things fall down, or even as load gets heavy or what have you. And that ends up being a lot of the power, because that's kind of key to scaling. So I think the other thing to understand is everything in Kubernetes is meant to be ephemeral. So any container is expected to at some point crash. Any node, any machine in the cluster that's hosting those containers is also expected to potentially go away, maybe because it crashed, or maybe because it just the cluster auto scaled down or auto scaled up. So quick review, you've got you hear about containers, but then as soon as we're in Kubernetes, we talk about pods. Pods are things that have one or more containers in them, and they also have volumes. The pods will get an IP address that's shared between all the containers, and those IP addresses are not predictable, and so we don't tend to use them very much. What you do instead is use labels. You'll see that in the demo, and then you've got the other one. Another one I'll give you real quick. 2 more slides, this one and the next. So we have nodes. Nodes are the machines, whether they're virtual machines or hardware, that run Kubernetes. They have a kubelet, which is basically a REST API, thingamabobby that runs at every node and basically ties the node to the rest of the cluster. You get some kind of container runtime like Docker, Containerd, so on, that's running containers. Kubelet's telling it what to do. You've got kubeproxy that's making some of the networking we're going to talk about in the next part work. The last part that's really useful for us today is a service, and you'll see us create a few services. A service is basically a load balancer, and you use them massively in Kubernetes because you don't say, I want to talk to this IP address. You basically say, I want to talk to any pod that basically matches these labels. And so the service creates a DNS name, an IP address, and a port. And anything you go and communicate to that IP address will go to one of the pods that has the label specified in that service that basically is supposed to answer for the service. So that's a refresher. Let's get straight into the demo. I've themed this demo. I love to do this with movies on the movie Real Genius. This may be before some of your time. To be honest, it's almost before my time. It was a movie in the 80s, and the one thing everyone seems to remember about it is that at the end of the movie, a house gets exploded by popcorn. So let's jump right into our demo. I'll tell you a little bit about the movie as we go through, and I hope you'll see it. If you haven't, and if you have, do like I did to make this talk and go watch it again. It's pretty neat. It was also featured in the not this year's but last year's Sans Holiday Hack Challenge. So here's our story. We are Mitch, and we're Mitch. We are an under 18 college student who's a genius and has been working on a laser, and we didn't realize that evil Jerry Hathaway is going to use it. He's giving it to the military to use as an unethical weapon, vaporizing human target from space. So let's get straight into our demo. We're Mitch, and the premise here is that Mitch is on a Kubernetes cluster already, not that this existed in the 80s, with the evil Professor Jerry Hathaway also being on that, and he's going to see if he can turn his access, his ability to run a pod on the cluster in the default namespace, and exec into it, into ownage and stopping Jerry Hathaway's evil plan. So first thing that happens, he looks at get pod, sees that there's a pod there, it's got an IP, he's going to go investigate it. And Jerry Hathaway is our guy in the picture that's just shown up in the lower right. And this should give you a sense for his personality. We curl his service and we get a web page that says, "You're laborers, you should be laboring. That's what you get for not having an education." He's kind of an asshole. This actor actually played a bunch of assholes in the 80s. But what this thing says is, hey, there's a PHP. This isn't Kubernetes. This is just, you have to find, sorry, the vulnerability, the first, we're training a couple of vulnerabilities. So anyway, it basically says, hey, the next line of code in this PHP running web page is something that's going to pull a specific file, not one that you name as an attacker, from this URL. See if you can use it. And he notes that he loves his house and he hates popcorn, which is part of his character. So this Mitch pod is already staged with some stuff. So the first thing we're going to do is use CVE 2020-8554. It's something that isn't easily patched, didn't just go away immediately because it ends up being kind of a works as intended vulnerability. And so what Mitch is going to do is he's going to create a service. And so long as he's able to create a service, he can monkey in the middle traffic that's outgoing to an external IP address. He's going to create a service. He's just going to call it "Not Afraid of No Ghosts." We'll see why later. He'll He'll set the app, the selector, label selector to Mitch, so that anything going to this service will come to him. And basically, this service is going to make it so that anything going to this IP address, 172.31.8.150 on port 80, is not going to leave the cluster as intended. Instead, it's going to go and hit any pod that has its label set, its app label set to Mitch. Where did we get this IP address? That's the IP address for Not Afraid of No Ghosts. Hey, Not Afraid of No Ghosts, it's a Ghostbusters reference, because the guy who played Jerry Hathaway also played Peck, the evil guy in, or the bad guy in Ghostbusters, who thinks that there are no ghosts and demands that the city shut down the ghost containment unit. That didn't go well for him. We're going to create that service. Mitch is going to create that service. And so now he should be getting any traffic that anybody in the cluster, that anybody's requesting of that IP address. So now what we're going to do is note that in Mitch's pod, we've staged, he's also staged an Nginx server already. And so in that Nginx server, he's created the static inclusion.php, except his is the very popular Pentest Monkeys, PHP reverse shell. You can find a copy in Kali Linux, or just searching the internet. And he set the IP, whenever you use this, you have to set an IP and you have to set a port. So he set the IP to not an IP address, but rather the name that a service called Mitch Rev Shell in the default namespace will get from kubedns or CorridorDNS. So what we're going to do now is basically we're going to create that cluster IP, that Mitch Rev Shell service, so that DNS will work. And that's just basically, our intent is just for that to land on Mitch's pod. Now, if you don't create a lot of YAML already, cool thing is kubectl has a bunch of these kind of generators. You see this dry run client where I can say, hey, I want you to make this, and actually give me the YAML that you would make so I can save it and put it in source repositories and modify it. So we're gonna write that out to a file, and then we're going to use sed and just modify it so that the app, instead of going to the default rev shell, since I don't have VI in this pod, can go to app Mitch, which is what this pod's answering to. So we've got our service. It's got the right app label. We're going to stage it, and then I'm going to run screen. We'll have two shells. We'll have one that's going to listen on port 444, and the other one's going to curl Jerry Hathaway's web server, so it'll pull the our PHP file and do that curl. And Bob's your uncle. We're now running code in Jerry's pod. So another movie quote I loved here. I was thinking of the immortal words of Socrates, who said, "I drink what?" It was hemlock, but yeah, cool. Anyway, hopefully that was a funny joke. I found it funny. So anyway, in Jerry's pod, there's a service count directory by default. It's mounted into every pod. So let's go and grab the token out of that. It's a JWT. We could decode it and see that it basically says what account it is on this cluster, and it's signed. So we're going to start up one more shell in our pod, and we're going to take that token and write it out to a file, and then we'll just do some kubectl, aliasing. So we're going to try to use the tokens. So Mitch can't list config maps, but Jerry Hathaway's token. I record all my demos if I, by the way, just because I hate the demo gods. Jerry Hathaway's token is allowed to get config. He's allowed to list them. Let's see if Jerry Hathaway's token can actually read them. Yep, it can read them. And I know this is really, really ugly, so let's take this stuff and run it through JQ and make it a little prettier. And then once we've run it through JQ, we can just look at the data section. If you're not super familiar with JQ yet, go and use it. It's a one-page tutorial, and it will save you so much time in all the things that do JSON. So we're going to go and take that data section and just grab the server and then base64 decode. And we can do that with each of the other components. We do that with the token, write that out to a token file. We can do that for the CA certificate that you need to interact with this server. And if we take all that and put it together, what's going to happen is we're getting access to a second Kubernetes cluster, this one being one that Mitch doesn't have access to already. it's the faculty cluster, and maybe that'll let us move laterally and get access we didn't have already. So here we go. We're going to take that whole thing, set it up in a kube control command, ask to get nodes. It says jury's not allowed to get nodes, but at least this tells us that we've got our whole kube control command, configured and working. Can't get namespaces. Well, that's kind of a pain. Okay. Well, at a certain point, we're going to ask what can we do. So let's set up. Let's take that line, and I think we had a little issue with the server, so I'm just making sure that, yeah, making sure we have that server. Cool. So let's take that line and set up as an alias. Do a get pods just to make sure things are working. We're able to get pods, and we're going to see if we can exec. Okay, turns out we can exec into Jerry's pod in that second cluster. So we're in the second cluster, the faculty only cluster. And our goal, if you remember the plot of the movement, it's totally okay if you don't, is to find out where this laser that we built that we didn't know was going to be a weapon is going. And so now we're in the second cluster, that faculty cluster, and now we just want to see if we can keep moving, keep escalating privilege. Cool thing that got added in kube control, we can say, can I do things, and get a list. Now this just consults RBAC if there are webhooks or what have you that have been added to this cluster, like you'll find in a lot of public cloud clusters. This won't be accurate to what they either restrict or allow in addition to RBAC, but says Jerry's allowed to create pods. I didn't mean for Jerry to be able to exec into pods, so our attack doesn't use execing into the pod we're going to create. So what we're going to do now is Mitch is going to create a privileged pod. And I know a bunch of you experienced Kubernetes people are like, that shouldn't have happened. And we'll talk about that in defense, because I'd agree. So Mitch is going to ask for a privileged pod. And a privileged pod is going to try to create one. It's called Jerry Priv to blend in. And that one's staged already. And so we've set that up, or Mitch has set that up with a web server, and with a little script that's going to not just launch the web server, but also do something else. And I'll show you that in a second. So we're going to curl that web server, and the web server is serving up the root file system of the container. And so we see that. But the cool thing is, when we're looking at that root file system, we can look at etc, but if we look at dev, in a privileged pod, dev has a lot of stuff that you don't find in normally in a container that's running in Kubernetes, or in Docker without the privilege, or in other container runtimes unless they're privileged. But we find, we might find SDA1 or SDA2. In this case, we find NVMe drives. We find the nodes, physical hard drives, or virtualized physical hard drives, right? And I've set up the entry point script for this container image to actually find every one of those drives and automatically mount them into a directory called hostfs. And so let's just take it on faith that the second one turns out to be the more interesting one. So in the second one, we find the hosts, the nodes file system, not the containers file system, which means we can go grab the kubelets, kubeconfig, which is going to have authentication credentials and configuration for the cluster. So we've now basically escalated privilege up to whatever the kubelet can do. And here's a little scene from the movie where, in order to find out where the laser is gone, our protagonists put sleeping gas into another student's room, and then go into the room and wire up his braces to act as a speaker, so that they can then claim to be God and convince him to answer their questions about where the laser's gone. So okay, so we've got that kubelets kubeconfig file. We're just going to use it on the command line on a kube control. We'll ask to get pods. We'll see that we need to, for one reason or another, we have to fix the server, the API server's IP address, but that's okay. We can do that. And when we do that, cool, get pods is working, which lets us know that our credentials are doing something. And we're just going to set up kube control now to use that alias. And so now I'll go and say, hey, can I get secrets? turns out the kubelet can list and read every secret in this cluster, because the idea being that any of the pods could get staged to the kubelet's node, and so it would need to be able to provide that secret. So that's a hell of a lot of useful thing. We see there's a backup namespace, and so let's backups. It just anytime as a Kubernetes pen tester, I see backups, I get really happy, because that's often where there's a lot of privilege and often data that's really useful, including credentials. So I'm going to go and pull the backup admin token, and we'll parse it with JQ and just grab that token straight out and base64 decode it and save it on a file. And we'll call that the backup admin token. And so I'm going to take kubectl now and use that token. Just do my get pods to see if everything's working. I'll ask to get pods that are in the backups namespace, and I see one. So it kind of has a nice, interesting name. It's not just backups, but S3 backup. Well, that could be useful. Something that can either read S3 to back it up or write to it. So let's just, I started to write some JQs so that I could basically wrap this command in another command so that I wouldn't have to copy and paste the name of the pod. And then it was like, no, wait, I'm doing too much work here. And the nested shell commands are going to get a little deep. So let's just do this. Let's copy and paste. Can we exec in? The kubelet can't exec into things. That's kind of cool. As powerful as the kubelet is, it still has some least privilege going on. It can't just exec into things willy-nilly. However, the backup admin credential is going to be able to. So we're just going to switch credentials. We write a tool called Peirates you're going to see in this talk, and it basically goes and tries to collect all these kind of credentials that all these tokens that we've been gaining and using, so that you can switch among them and do things. So we're going to do AWS S3. We see some buckets. There's a COP state store. That would be awesome to be able to read into. There's a Pacific Tech. Oh, there's cluster access for an Air Force, and I've spelled it differently just to just so that when I'm staging this on AWS, I wouldn't scare anybody. So it's AFUS instead of USAF. But let's go and look at that cluster. By the way, I should note the first two clusters that we did. We're about to go into a third cluster. The first two clusters were Amazon EKS clusters. And so that, if you're a defender, you should note that that your cloud provider, they do a lot. They do some, but you have a real security obligation. You have some serious responsibility on the hardening side and least privilege side. So let's take a look at that bucket. We see just one file, so let's go and pull that file down and just copy it. And when we look at it, turns out, oh, that's basically a kubeconfig file for Don Carnagle, who's the major, the Air Force major in the movie, who's telling Jerry Hathaway that he better have the laser done soon, or else his project could get audited, and then they'll notice that he's been misusing government money to renovate his beautiful house. Hence the reason the house has to go at the end of the movie. So we're going to try using Don Carnagle's kubeconfig file, and it can't list nodes. Okay, can't list pods. Well, that doesn't sound very useful. Oh wait, but it says in the namespace backups. Well, cool. Let's try the default namespace. In the default namespace, we can see something, and this is cool. We see badge access, and just keeping in the spirit of the movie. In the movie, our heroes have to sneak onto the Air Force base, so they're going to do it by creating fake badges. And so, I want to go a little further here and say that this cluster is using kube2im as a defense. And the cool thing about kube2im is, or part of what that's trying to do is, normally if I'm in a Kubernetes cluster in a cloud environment, I can reach out to the Metadata API and ask it for temporary security credentials for my role, and my role will be the role of the node that I'm running on, which isn't very granular and can have a lot of privilege right out of the gate. If you run kube2im, then if you get whatever's been defined for the pod you're in, and if nothing's been defined, you get the default, which will be empty. So this isn't really great as an attacker for me to see this kube2im default. And I'm just going to move forward, and I'm going to take my kubeconfig file. I've staged it up. I'm going to try and get a list of namespaces. Darn it, I can't even list namespaces. This is kind of painful. Let's find out what I can do. That auth can I list? Oh, wow, I'm allowed to exec into pods. Well, in this namespace, well, that'll be very useful. So I'll exec into that badge access pod. And in that pod, I will, I'll use that pod's AWS IAM account to list out S3 buckets. And I'll see that there are 3. There's a COP state store. Now that would be hella useful because, as you'll see, this cluster was built by COPS. It keeps a state store, and kind of the default instructions will put that state store in an S3 bucket on AWS or in a GCS bucket on GCP or so on. If we can read that state store, we get great things, as you'll see, because we're going to in this. So we can't read it. Darn it. Okay, even if we had our S3. So let's curl the metadata API and just see what our role is. Okay, so kube2im has assigned us a role, Kubernetes S3 access for badge access list. So I can probably read the badge stuff, but I can't read that COP state store. I'd like to see if I can find another way to it. And so here's what Mitch is going to do. So by the way, this is them sneaking onto the base. There's Val Kilmer on the right. So Mitch is the guy on the left. I'm going to try something else. Let's assume I couldn't have privileged pods. So we're going to try something. We're going to try a different thing. I'm going to say I'd like a host network pod. And the host network pod is one where instead of the pod getting its own IP address and its own kind of, network namespace and thus, its own set of network interfaces, it's just going to get the one from the node. This is, again, something that you don't want to allow, and you're about to see why. Mitch is going to create that pod and exec into it. And from within that pod, if we curl the metadata API, we're going to be using the node's IP address. We're not going to get translated into something else. We've got the node's cloud account. What I'm going to do now is switch to using Peirates, but this is an attack that's pretty easy to do manually. It's just takes more typing. So I'm going to run kube control get pods on all namespaces, ask for YAML, and I just want to grep out for anything that says ARN, these AWS IAM roles. And we've already seen this one, the Kubernetes S3 access for badge access list. But let's try one of the others. There's one of these that looks pretty interesting. This thing that says S3 and EC2 read only. That sounds like almost like as bad as the old primitive roles that you'd see in cloud accounts. So it's probably overprivileged. So let's take that stuff. I've just copied that, and I'm going to launch Peirates. And so in Peirates, I've got a bunch of features. So this is kind of a rough and ready tool. So it's written in Go. We're happy for any collaboration you want. It's on GitHub. I'm going to go and say, hey, go and grab that AWS. Go and grab an AWS, temporary credentials from the metadata API. And it does that, and that's already loaded. That's now loaded, and so we're told, these are the ones that these are the credentials that we're on right now. And now what I'm going to do, we've already tried using the nodes account for S3 listing, and that didn't get us where we wanted to go with the COPS thing. So we're going to actually try to assume a different role, because part of the way kube2im works is basically a node will have to be able to assume any role that's in use, that's going to be in use in a pod that's staged to it. And so some of our guys, Rob Curtin-Seifert, Thomas Hutchison, and Jareth Kelly, wrote a tool that we have internally. It's not shared. It's even rougher, but it's called Hold My Beer, where it was like, hey, you can't do that. There are 34 different, how are you going to iterate through all this? There are 34 different roles and all these different buckets, and basically created something to do this. So Peirates does this a little bit more manually, but I can say I'd like to assume this role. Amazon's SDS service lets us. And so now Peirates says, okay, you've got the assumed role there. And so now I'm going to try this automated pull the service count tokens from an S3 bucket, from COPS's S3 bucket, if you can find it, and if you can read it. And so we try this and we say, hey, we want to store all these. And so I'm going to show you that will be really, really fast. So here's what happens. First, it just tries listing all the buckets. And then for every bucket that it can list, it lists the objects of the buckets. And any of those objects that match Cops's store for these, for these Bootstrap tokens, it'll go and decode the tokens. And this first one we're going to see right here. And I know I'm running short on time, but we may go over just a couple minutes into lunch, but we're almost done. So we've got a bunch of tokens. The very first one is basically cluster admin token. And with the encoded version, with the decoded version, I'm going to copy paste that so we can use it manually too. But now at this point, if we run SA menu, service count menu, in Peirates, it'll say, these are all the different tokens you got. Do you want to switch to one? Yeah, we'll switch to that cluster admin one. Thank you very much. And now I'm going to switch namespaces. There's a namespace called laser. Well, I'm trying to get the laser not to point at their intended target, but instead to point at Jerry Hathaway's house to ignite the Jiffy Pop and make all the popcorn flow. So let's switch to the laser namespace. Let's list the secrets out. And any of the secrets that are service counts it'll identify, but we're not interested in that. We're interested in the house coordinates secret and the laser target coordinate secret. So let's use that target coordinate secret. We're about to end. So we exit Peirates. I'm going to just set up kube control to use that cluster admin token that Peirates grabbed for us, and to default to the laser namespace. Ask to get secrets. Let's take a look at the target coordinate secret. And that target coordinate secret is just pretty simple. It's got a latitude, longitude. Well, okay, let's look at the house coordinate secret. Let's see if, maybe it's got coordinates. We can just move them into the target coordinate secret. Oh, cool, it's got a latitude, longitude. It's exactly the same. Well, then in one fell swoop, let's delete the target coordinate secret and then change the name of the house coordinate secret by getting it and, making a copy of the house coordinate secret. And making that copy called target coordinates. And now the laser is going to zing Jerry Hathaway's house. So that's our demo. And I think what I'd like to do is talk about defense in the channel, in the Slack channel, unless Frank breaks in and tells me to go a few more minutes.
Yeah, no, this is a good stopping point here. So, I know this
Perfect.
is your last slide. And before we break here and send everybody over to Slack, we do have one question. We got time to take one question. Hey, that was, people were chiming in here on chat and saying, hey, they loved seeing all of the command line and picked up some tips and need to go back and rewatch to make sure that they got all these little command line tricks down as well. But there was a few times where you showed the token, right? Obviously, to go from one cluster to another. Somebody asked earlier on is, hey, can you just explain quickly conceptually how you use the token to get access from one cluster to the second cluster?
Yeah, sure. I'd be happy to. So, so the idea, and we made two hops. I'm just trying to remember the first of the two. So the idea was if we found a static credential, like service count token, or in this case, like a user, like a user credential, then we can just basically plug it into kube control. And we don't have to plug it into kube control from within any of the clusters. We literally could be doing, as long as we can reach the API server on the cluster from somewhere out on the internet, then we can, communicate to that API server. And all we got to do is basically pass it a token. And that tokens we were using were JWTs, JSON Web Tokens. And they basically they're kind of really simple. They're just these assertions that are signed that say, I am this principal, this, user, this service account, or what have you. So yeah, that's basically, we found one of those and got to use it. Kubernetes, there's been some work in Kubernetes to start having more rotation, so you don't have those kind of static credentials that might still be working 6 months or a year, or a year or 2 years later. Yeah, so I think that's probably a good stopping point for the question. Hope that helped.
All right. Hey, awesome. great presentation, great demo. You know, I'm going to go ahead and shift the conversation over to Slack. Everybody, let's give Jay a round of applause. Thank you so much, Jay, and take care. We'll see you at the next one.
Thanks a lot. I'll see you all in Slack, and I'll be enjoying other talks here.